Alright, in this video we'll talk a bit about indices, and before I start talking about it, I'll just introduce you straight away to what this is all about. This number here, well, I use letters to demonstrate it, is called an indice, or a number with a power, and we have them around us all of the time. Now, introduce you to a few terminologies before we get started. The big number at the bottom is called my base. And so if I mention the word base, you know I'm talking about that number. And the little number at the top is called my power or my index. So keep an eye out for those words. I'll be using them quite a lot. All right, the laws of the indices. Now, I'm going to number these laws. So this is 1, 2, 3, 4, 5, 6, and 7. And what I will do is I will go through the laws, explaining them one by one, giving you examples. So, for example, the first law says that if I've got a number, well, if I'm multiplying two indices and they have the same base, remember what the base is, it's the big number at the bottom. If the base is the same, all I need to do is rewrite the base and add the index or the powers. Well, let's put this into practice. So let's just say I've got 4 to the power 3, and I'm multiplying that by 4 to the power 4. Then, because as you can clearly see the base is the same, they both have a 4, I'll write back my base and I will add the powers. So 3 plus 4, and the powers I'm talking about are these powers here. So I'll add those powers up, 3 plus 4. So my final answer is going to be 4 to the power 7. And that is law number 1 done. Alright. I'm going to skip to law number 3 actually. So if you look back again, law number 3, have a good look. Now law number 3 tells me that if I'm dividing now, so like for example, if I've got a to the power m divided by a to the power n, and for some people I will write this in a different way because some people get this really confused. So a to the power m divided by a to the power n. So now it looks like a fraction. It's the exact same thing. Well, the law basically states that if the base is the same, remember what the base is, base, the big number at the bottom, if the base is the same, rewrite the base and subtract the powers. But I want you to pay careful attention to what I've actually subtracted. I've subtracted the first number subtracts the second number. That's what it is. And especially when we start dealing with negative numbers, that will become particularly important. Well, all right then. Let's take, for example, a similar one that we've done to show this rule works. So I'm going to choose different numbers now. 3 to the power 5 divided by 3 to the power 2. Well, they're dividing and the base is the same, so the law says I should just rewrite the base and subtract the powers, which is going to be 3 to the power 3. And you can leave your answer like that in index form. Alright, let's move on. We're going to now move on to law number 2. And law number 2 basically says if I have a to a power or a number to a power, and those are in a bracket, and the bracket itself has a power, then what I do is rewrite the base and multiply the powers. Just multiply the powers. So, alright, let's look at an example yet again. So I will now use the same thing I've used just above there, 3 to the power 5 in brackets, and the brackets itself has a power of 2. Well, basically what this means is that I write the base back and I multiply the powers 5 times 2, giving me a value of 10. And that is now finished. Alright, we're going along quite nicely. And rule number 4 now. Well, there's something unique about rule number 4. Rule number 4 basically states that if I've got a and the power is negative, what I need to do is reciprocate to make the power positive. So all I need to do is flip the a over, and 1 over a to the power m. Now, you might be wondering, where does that 1 come from? You know, this is very confusing. Where does that 1 come from? Well, I will use this opportunity to make a very radical statement, and that is, all numbers are fractions. Listen to that again. All numbers are fractions. Let's take, for example, the number 4. Say, whatever, 4. Well, you might look at it and say, well, it's just a number 4. It is not a fraction. Well, it is. And the reason why it is because all numbers, unless otherwise stated, are over 1, which makes it a fraction. It is a fraction. It's divided by 1. But because it's divided by 1, we don't really acknowledge the 1. We just say that, well, the number is 4. But it's actually 4 divided by 1. Now, that being said, if I reciprocate or flip over that 4, then automatically you can therefore see that it becomes 1 over 4. So just the same way, and actually 1 over 4 is the opposite of 4. It's like the inverse of just 4. So if you multiply it, you'll get 1, but that's another story for another day. So underneath this a, there is a 1. It is a fraction. So if you want to make the power positive, you reciprocate, that 1 comes on top, and as a result of that, you've got 1 over a to the power m. Now, putting it into practice, let's just say I had 2, let's just say I had 2 to the power minus 3, and I want to make that positive. Then using the rule, it will give me 1 over 2 cubed. And by the same vein, if I've got 1 over 2 to the power minus 3 and I want to make that power positive, I can reciprocate again and get 2 to the power 3. So it works both ways. Alright, that's fantastic. Now, we are now down to the last 3 rules. I will merge rule number 5 and 6 just to bring this to an end. Merge rule number 5 and 6. Okay, let's have a look here. So rule number 5 now basically say that it says if I've got a to the power 1 over n, it's a fractional power, then that basically means the n root of a. Alright, now you might be wondering what that is. Well, let's look at an example here. So if I have 2 to the power 1 over 2, then that is the square root of 2. But you might be saying to yourself, well, hang on, there was an n here and the n automatically came there. So why didn't I put the 2 over there? Well, there's a reason for that. This is called a square root. Get it? Square root. So you don't need to put the 2, otherwise that would be redundant. Now, if I, however, do 2 to the power a third, well, that's a different case now. Now the 3 comes outside, and that becomes the cube root of 2. Now, by the same token, I can actually look at, I'll go over to a new page for this one, which basically says a to the power m over n is going to equal to the n root of a to the power m. And what this basically means is that the denominator becomes, outside here it becomes power of the root, and your numerator becomes a power of the number on the inside. So you can see this is the m becoming a power just there. Alright, now let's put this into practice. So let's just say I'll use the same 2 to the power 2/3. Then to find the answer to this, it's going to be the 3 comes outside by the square root, so the cube root of 2, and numerator comes inside square there. And if you want, you can go and work that out. And the very last rule basically says a to the power 0 is equal to 1. Well, basically, long and short of that story is anything, regardless of what it is, even if I have x plus 5 plus x squared in a bracket, doesn't matter what it is, so long as I put that to the power 0, the answer is going to be 1. Okay, so those are the rules explained about indices. I'm going to stop this video now, and then I'll do a completely separate video looking at some examples on how to solve questions using these rules.